Okay, today's learning objective, students will describe patterns and use inductive reasoning. So what is inductive reasoning? Inductive reasoning is where you find a pattern and you make a conjecture. So you might be wondering, what's a conjecture? A conjecture is an unproven statement based on observations. An unproven statement based on observations. So essentially, it's an educated guess. Okay, and so in order for a conjecture to be true, it must be true for all situations. So if you find just one time where it's not true, then it's false. So in order to be true, it must be true for all situations. Okay, so inductive reasoning, we're finding a pattern, so remember that. Inductive reasoning has to do with finding patterns. Later on, we're going to be learning another kind of reasoning, so I want you to be able to know the difference between them. So inductive reasoning, we find a pattern, we make a conjecture. Conjecture is just basically an educated guess on what we've observed. And the last term I need to talk to you about is a counterexample. A counterexample is an example that would show that a conjecture is false. And as soon as just one thing can show it's false, then we know the conjecture is false. So it only takes one counterexample to prove that a conjecture is false. Okay, it only takes one counterexample to prove that a conjecture is false. So if we go down here, we've got an example where we're going to be looking at patterns and we're going to make a conjecture. So we're given 5 non-collinear points and we're going to make a conjecture about the number of ways to connect the different pairs of points. So we're going to see if there's a pattern as we increase the number of points. So first we have 1 point, and that point's not connected to anything. So there are 0 connections. In the column of 2, I can connect it just 1 time, so there is 1 connection. If I have 3 points, I can connect it 1, 2, 3 times, so there are 3 connections. When I have 4 sides, there's 1, 2, 3, 4, 5, 6. So I have 6 connections. So before we go on to 5, let's take a look at what's happening here. When I went from 0 to 1, what did I do? I added 1. When I went from 1 to 3, I added 2. When I went from 3 to 6, I added 3. So we can make a conjecture that if I go 1 more, I'm going to be adding 4 to that. And so then that would mean 6 plus 4, there should be 10 connections. So that would be my conjecture, is that there will be 10 connections between the points. And we can double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough, there are 10 connections. So what do you suppose we're going to be adding to get to the next one? we would do plus 5, and so on. So my conjecture based on that pattern would be that the difference, so here's my conjecture. My conjecture is that the difference in the number of connections is increasing by 1 each time. So I'll write that down. The difference in the number of connections increases by 1 each time. So, like we said, if there was 6 points, I think it's going to be plus 5, so 10 plus 5, there would be 15 connections, and so on. Okay, so we have another example here. We're going to make and test a conjecture about the sum of any 3 consecutive integers. So first we're going to see if we see a pattern. So we're going to add up 3 plus 4 plus 5. So 3 plus 4 plus 5 adds up to 12. 10 plus 11 plus 12 adds up to 33. 7 plus 8 plus 9 adds up to 24. And 16 plus 17 plus 18 would add up to 51. So I want you to look at those numbers and see if you can see a pattern of a relationship between the answer and the numbers that are being added. So pause the video, take a minute to think about it, see if you can find the pattern. Pause it now. Okay, if you're getting stumped, I'll give you a hint. Let's look at that middle number. So now that I've highlighted the middle numbers, can you see the pattern? Hopefully you can. What the pattern is in this case is that the sum of 3 consecutive integers is equal to 3 times the middle integer. 4 times 3 is 12, 11 times 3 is 33, 8 times 3 is 24, 17 times 3 is 51. So my conjecture is the sum of 3 consecutive integers is equal to 3 times the middle integer. So step 2 now, we're going to test it by using some other numbers to see if it still works. So if I add -1 plus 0 plus +1, that adds up to 0. And the middle integer is 0, and 3 times 0 also equals 0. If I add 100, 101, and 102, that adds up to 303. And again, the middle integer is 101, so 3 times 101, I get the same thing, 303. Now obviously you can't test it forever and ever, but you can see that at least in these 2 cases it seems to be working. Okay, so here's another conjecture. Here's another conjecture. We're going to try and find a counterexample. The conjecture is the sum of 2 numbers is always greater than the larger number. So is there a counterexample we can think of this? Well, anytime you add, if one of them is negative, then the result's going to be smaller, right? So a counterexample could be anything where, say, 3 plus -4, that equals -1. And so it says the sum is always greater. So is -1 greater than 3? No, it isn't. So you've shown that it's false, and so therefore the conjecture is false. And these 3 little dots, that means therefore. Okay, so because -1 was not greater than 3, you can say the conjecture is false. Okay, now we've got another one here. Supplementary angles always form a linear pair. Well, in order to be supplementary, the definition says that the measures have to add up to 180, but it doesn't say that they have to be adjacent. So for this one, you could actually just draw your counterexample by drawing angles that are not a linear pair, but whose measures still add up to 180. Okay? All right, so that concludes inductive reasoning. Thank you.